All right, gentlemen, let's take a look at some review material of everything we've covered since that take-home test. And this will be good preparation for our Exemplify quiz, which will be on either the 7th or the 8th. And that's day 3 or day 4. And again, it'll be on Exemplify. All right, I don't know how many questions yet, probably about 15 or so, and it'll be basically on all this material. So okay, and after this video, and after you take these notes along with me, there's a classwork assignment, and again the answer key will be posted at some point, probably the next class day for you to study from for the test. Okay, so just a couple things. At this point, I think we should know this, but just a little bit of a review that logs are exponents. So our answers to these questions that you do without a calculator are the exponent. The answer is the exponent. So we see here, base is 6, raised to the what gives me 1. We know that whenever I get 1, the only way to get there is to raise something to the power of 0. Same thing over here, log of, and this base is a 10. 10 raised to the what gives me 1 over radical 1,000. Well, we know how to get to 1,000, and that would be a 3. But it's on the bottom, so it's a negative 3, and it's in a radical, so it's over 2. Negative 3 over 2, and that's the logic I use. 10,000 is a 3. On the bottom is a negative. Under a radical, over 2. Same one over here. Base is 4. Raised to the what gives me 64. And that would be a 3, right? 4 times 4 is 16. 16 times 4 is 64. ln, now new base. This base is e. E raised to the what gives me 1. We know that anything raised to the 0 is 1. Similar type questions right here. Okay, looking at 5 through 8, another one, e, this base is e, raised to the what gives me 1 over e to the 7th. Well, that's definitely a 7, except it's on the bottom, so it's a negative 7. Right? 6, 7, and 8 were what we used when we were solving logarithmic equations, where we looked at this base, which is a 10. If they were the same, these canceled out to be a 1, and your answer was just the 14. The base of the natural log is e, so that cancels out, and you just get the 5. The base is 7. The base of the exponent is 7, so they cancel out, and you just get a 3. And the whole premise of that is we were matching, we were doing this on purpose in order to get it, in order to be able to solve for x when there was an x up here or up here or up here or something like that. Okay, so I think those first 3, hopefully I know you guys did very well on that part on the homework, so I hope this is just a quick, easy review. Couple review and expanding. I know the change of base was trouble with some people, and then sometimes double negative. So let's go through a couple of these. So we see here we want to write this single log as a couple logs. So we know that, just a couple rules we have, that when we see multiplication, that means add some logs. When we see division or a fraction, that means we're going to subtract. Okay, so this single log, first thing I'm going to do is write it as all individual logs, x squared plus, because I'm multiplying, log y to the 3rd minus log z to the 4th. You can do this if you want. You don't really need to. Right? And the other rule, which we saw, and I think for the most part, pretty much across the board, people did well on understanding, was that the power comes out in front. So this 2 comes out in front, the 3 comes out in front, and the 4 comes out in front. It's called the power rule. So 2 log of x plus 3 log of y minus 4 log of z. And there is my answer. Again, I could write it like this if I wanted, but that's fine. I have my powers in front, my subtraction and my plus signs, and then obviously to go back, we should be able also to go back. No problem there. Nice, easy first one. Let's look at the second one. Some people had trouble here when they saw the base, right? This base is 10, and you just carried it throughout. Same thing, this base is 2. You don't do anything to it differently. You just carry it throughout. So you have over here, log base 2. Okay, then we have on top a z to the 4th minus log base 2 x to the third. And then, right, I'm going to go like this and just put a plus because these two are multiplying. So in parentheses, these two are multiplying. Oops, I apologize. And we had log base 2 of a radical y. Okay, so here's my log base 2 throughout. Z to the fourth is first, and then we have minus these two things multiplied. So there's my plus. Okay, log base 2, the 4 goes out in front. There's my z. 2's and z's, a little confusing. Now, this is where some people messed up. Well, I'll do this first. Minus 3 log base 2x plus, and most people got this fine, log base 2 of y with the 1/2 in front. This minus sign could get distributed inside, and then you have 4 log base 2 of z minus 3 log base 2 of x minus 1/2 log base 2 of y. And that's how we would write it. Right now, when we saw this, a lot of people tried to write this, right? Like z to the fourth over x to the third over radical y. And I understand that because there's a minus and then another minus. So we would think that it's like a double fraction, but that's not the case, right? If you view it more like we have right here, where the parentheses is grouping these, and then here's my plus sign, that's only turning minus because of that minus sign being distributed. I think that helps clear up why this is not true when we see what's boxed up above. Okay, if it helps you to write the parentheses, great. And then going backwards, I guess I would just kind of either remember that or just try to take out a -1. You could do that too, but I think I would just kind of memorize that this is really just saying that x to the third and radical y are both on the bottom. Okay, let's look at the next one. We see that the whole thing is under a 1/4, so I can just do this right away. Take the 1/4 out of everything, and now we see divide. We know that that means natural log of x minus 1/4 natural log of y. You could also write it, I guess, as something like this: 1/4 natural log of x minus the natural log of y. They're really both the same. Either one is fine, right? But the 1/4 can come out of everything. Zoom out a little bit. So now this is where I think people made the most mistakes. Change of base, right? This is technically not expanding. It's probably actually the opposite, writing it as a single log, but I just threw it in here. Change of base. When we see a full log and a number, and another full log and a number, as we see here, right? These bases are 10. Okay, we write this as a single log, as this 6 is here, and then the 10 stays up top there, right? This base right here actually does not at all play into effect here. That doesn't matter. I think what the problem was so some people were viewing it as this type of a problem, where if I had log base 10 of 8 over 9, that would be log base 10 of 8 minus log base 10 of 9, right? When the full log is divided by another log, we write it like this, right? This is one thing when there's a division on the inside. When the whole things are being divided, that's when we do change of base, right? And as we see here, this number on the bottom is the new base, and then this number on top is the new inside. Right, so I think that's where the most mistakes occurred. Be careful on that on the quiz. I know that we're going to have one of those. I'm sure we will, and I foresee that being the most difficult or the problem that trips the most people up. So just be careful on that. Okay. Condensing logs, we'll do a couple of these. The one I just did above was kind of the same idea. Okay, natural log, my base is here, is e for both of them. Not that it really matters, but the natural log, x to the third and a y, going backwards, the 3 is an exponent to the whole thing in parentheses, and then the 2 is an exponent to the whole thing in parentheses. As we saw in the first trimester, when we have a power raised to a power, we multiply. So we get over here, natural log of x to the 9th, not 6th, y to the 3rd, plus natural log of y squared z to the 4th. Okay, right? Since these logs are the same, I can combine them. Natural log, it is plus, which tells me multiply, so x to the 9th, y to the 3rd, y to the squared, z to the 4th. Why are there two y's? That's okay, we can combine them, right? Our rules of exponents, when we have an exponent timesing an exponent, when we have a number with a power times a number with a power, we add those powers. So here's my total answer right there. A nice little review of what happens when we raise a power to a power and when we multiply things with powers. Good. Okay, next one. Right, and this is kind of going back to the idea of this double minus sign, right? It does not mean it's like a compound fraction. It means that those two things are really multiplying on the bottom. Okay, and some people got tripped up with this. Log base 2, base 2, base 2, base 2. All base 2, so we are allowed to combine them. Log base 2 of x plus, I see the 4, it goes up top. Log base 2 of y to the 4th. Okay, I'm going to change this to the way we started before, minus, parentheses, log base 2 of z, plus, right, if I put this parentheses here, I'm like distributing out a -1, log base 2 of m to the 5th. Okay, right, so now that whole group is in parentheses, and it's adding. You don't need to write the step if you kind of can see it as we saw above, that this just means the whole thing's on the bottom. If you remember that, great. If not, you may need to write this to help you remember it. Okay, they're all the same base, so the first thing I could do is log base 2. Plus means multiply. Minus means it's on the bottom. And then these two things are multiplying, a z and an m to the 5th. Right, so just to write that a little bit neater, log base 2, x, y to the 4th, z, m to the 5th. And here is my answer. Right, so I hope this example with this and showing this helps clear up, because I think most of us kind of got this part right, but got a little confused on how to go from here back to here. So going from here to here, most people did fine on, but going backwards confused them. So I hope this example and this example help clear that up. Okay, let's just do two more, nice and quick. Log base 10, they are the same base, so I am able to combine log of xy all raised to the 4th minus log base yz all raised to the 3rd. If I had if I had just log of y with a 3 in front of it and then minus log z, then the z wouldn't get the exponent of a 3. But because they're in parentheses, they both get it. Okay, minus means divide. Nice simple answer from here. X to the 4th, y to the 4th, y to the 3rd, z to the 3rd. We see a little thing happening right here, right? We have this y to the 3rd and this y to the 4th. Bringing us back again to our rules of exponents that we saw in the first trimester. X to the 4th, z to the 3rd, but these y's I can simplify to just be a single y on top. Nice way to take our things that we learned from the first trimester, our exponent rules, and kind of use them in logs because we know that they're related. Okay. Looking at the next one, two ways to do this. I'm going to do the first way in blue and the second way I'll do in green. We see that everything is a fraction, which means that everything is really just in some form of a radical. All the bases are the same. All the bases are 4. We can combine. Okay, so first, log base 4 of x to the 3 over 2 plus log base 4 of y to the 5 over 2 minus log base 4 of z to the 1/2. Okay, so I just took all the exponents, or all these numbers in front, and made them exponents. Okay, a plus and a minus, very simple. Log base 4 we can put everything as 3 over 2, 5 over 2, and z 1 over 2. Now you can write this a couple ways from here, right? So log base 4, you can write it like this, right? Square root, and square root. But then when you see that, you should be able to picture that and say, well, I could just, everything's in an index, a radical with an index of 2. So I can really just put the whole thing under one single radical. And there would be my fully simplified answer. Brings us back to what we saw in the beginning of the year with radicals. Okay? All right, so let's look at how could you do this another way. The other way to do this would be, see, from the beginning, you have a 3 over 2, a 5 over 2, and a 1 over 2. So it's really like a GCF of 1/2. And we have, when you take that out, it's 3 log 4 of x plus 5 log 4 of y, right? Taking out a GCF of 1/2. And log base 4 of z. Here we go. So there's my 3, my 5, and my 1, which are from the top, and I took out my GCF of 1. And it's really easy to see how this equates to that. Right? Here is my 3, my 5, and my 1. 3, 5, and 1. All of them are base 4, which I just keep right here. There's my base 4. And then the 1/2 is over everything. That's a radical, right? So either way, same difference. Nice problem to view. You get the same answer by doing it any which way. All right, let's do a couple of these, just 4 more. And I just did pick some of the hard ones. So we see over here, when solving, these are exponents, which means I have to use some form of a log to undo it. I want to pick a base that matches. I could do either 3 or 4. Doesn't matter which one I pick, so I'm going to do base 3. Why? It's just on the left, so I'm going to choose that one. Okay, so log base 3 of, and log base 3 of. Okay, 3 to the 2x plus 4, and 4 to the x plus 5. Okay, so I just take the log of base 3, which I chose to match that. It doesn't match that, but that's okay. I chose it to match the one on the left. And now, what happens here, as we saw, I'm not going to go through the whole mess again, but these two cancel. So you have 2x plus 4 is equal to, but this you can't cancel. So the only way to undo it until I kind of get it out is there's my x plus 5 timesing log base 3 of 4. Right, so we move the power inside the log out, but then what do we do next? The kind of annoying couple steps of distributing this in, and we get x log 3 of 4 plus 5 log 3 of 4. So I distributed from this unit, my log base 3 of 4 that I can't break apart, and I put inside, and I just take the x plus 5 and I distribute it. Okay? Okay, so here's my 2x plus 4 on this side. That does not change. All right, and now what I want to do, I want to get the x's together. So now everything that's not an x, I'm going to move over, and everything that is an x, I'm going to move over this way. Okay, so let's start with 2x minus x log base 3 of 4 equals 5 log base 3 of 4 minus 4. Again, the minus 4 stays on the outside. It does not touch the inside of the log base 3 of 4. All right, so now I have my x stuff, just like we saw when we did inverses. We want to essentially like take out a GCF. So we're taking out an x, and we're left with what? 2 minus this log base 3 of 4. Right? And as the example I did in the other video was kind of view it as if I were to do 2x minus, let's go with 3x or something like that. Right? We would view this as, oh, that's negative 1x. But how do you get that? Really what you're doing is you're almost GCFing out your coefficients and then doing your subtraction. Kind of the same idea. My coefficient of x and my coefficient of x, which is on the wrong side, those are the things being subtracted, and the x stays on the outside. Kind of like a GCF, however you want to phrase it. Okay, so there's that. And now on the other side, I still have, nothing has changed here, my log base 3, 4 minus 4. I'll show the last line over here. We want to divide both sides by this mess in order to get the x by itself. So my x is equal to 5 log base 3 of 4 minus 4 over 2 minus log base 3 of 4. And here is my total answer. A lot of work for one big decimal. Okay, if you did it the other way where you chose your base 4 to start, this would cancel. You'd have a lot of x plus 5s floating around. And then over here, you'd have a log base 4 of 3 to the 2x plus 4. Doesn't really matter. I chose it this way. A lot of log base 3 is my answer. Okay, let's do the next one. Log base 2, base 2. Okay, so now I know I need to do 2 raised to something. That's what I have to do here because my log base is 2. But first, before I could do anything, I want a single log. I want to get the logs by themselves. But these, although the same, it's not alone. I have 2 of them. How do I make it one of them? Well, we do our rules of combining. So you have log base 2, x times x minus 3 is equal to 2. Okay, so here's my base 2. Here's my base 2. I combine it because plus means multiply, and I multiply these. So let's just make it a little bit neater. X squared minus 3x is equal to 2. Okay, now to undo a log base 2, we want to raise everything to the 2. Okay, log base 2 of x squared minus 3x. Okay, and now these cancel out just as we saw up above to a 1. And I'm left with x squared minus 3x equals 4. I can't solve for x here, but what I can do is that of these two, right, I cannot get x by itself, so I have to bring the 4 over. So I have x squared minus 3x minus 4. We didn't see this in the video, but you can factor. It's normal. Just like when we were solving and you solve for x. When you solve for x, when there's an x squared and an x, you can't get x by itself. So you need to find two numbers that multiply to negative 4 and add to negative 3. And here are my two answers. Okay? You get 4 here and you get negative 1 here. Right, but our only answer is this because this negative cannot go in there. Right? You can't get negative, so we need positives. Right? Just like we saw on the first day with the graph, like once you got negative numbers, it got really weird, so you can't use the negative number. Right? So this one is thrown out, and there's your answer 4. Right? So there's our work for number 18. I hope that cleared up some little, kind of like a new version, but I hope that kind of cleared up some of the steps. Let's just do 19 and 20. Kind of two more of the same. Bring over my 30 because I want the e by itself. Okay. I want the e by itself, so I divide both sides by 3, and I get my single number 10. We know that e, so I need an ln of both sides, a natural log of both sides. Natural log and a natural log. And I have e to the 2x and a 10 here. Okay, so I took the natural log of both sides. We know that this e and this ln cancel, so I just get a 2x, which is nice, but this natural log of 10 does not disappear. Now my answer is just the ln of 10 divided by 2. And there's my answer. Nice simple one with e. Okay, and e goes with ln. My logs, I have to match the bases. So this was base a 3 that had to match with a log base 3, and this I had a 2, so I had to match it with that 2 raised to the whatever. Here's 1. These are base 10s, so I know I'm going to have to do a log base 10, so just log. What about up top here, right? So I have some x squared stuff up here, so I'm probably going to have to do the same factoring I did up above over here. Okay, but anyway, let's look. So we have 10 x squared minus x. So we need to do log of both sides. Okay, in order to solve for our x, we have here equals, there's my 100 in there, here's my 10x squared minus x. We know that this will cancel and give me just a 1. And I have here x squared minus x is equal to, but we can actually simplify this, right? Logs are exponents. This is a base 10, so I think I can do something pretty nice here. 10 raised to the what gives me 100, and that's just a 2. We could have also technically changed this to 10 squared and done what we had done in the first part of the video. When you have the same base, you can just set the exponents equal to each other, which we kind of have here as well. Same difference, doesn't matter. If you forget to do it, this works out just the same. And if you were to forget at the end and you just leave as log base 10 of 100, you would just get a really nice answer of 2. I mean, it should be clear that if you have an x squared minus an x, this should come out to something nice. I'm not going to make you factor with this thing. It's going to come out to something kind of nice. X squared minus x minus 2. The only way to solve for x when there's an x squared and an x is factor x minus 2, x plus 1. So we get an answer of 2, and x is negative 1. Okay, so there's a little review on some of the stuff we've covered over the past couple days. Good luck. I hope this video helped clear up a bunch of the confusion, if any of you had any, or just to give you an idea of what we've just kind of summarize everything. You have a classwork assignment, and then that'll be due at 7 p.m., and then your quiz is on Tuesday or Wednesday on Exemplify, right? Okay.